Good morning. Welcome to Thursday morning. This is part 4 of the ADA self-evaluations, transition plans, and overview of elements of PROWAG. I'm Victoria Beal with the Ohio LTAP Center, and I have with me my colleague Ron Eck from the West Virginia LTAP Center. He is their director, and he will be providing the content of today's webinar. Ron is a national subject matter expert in these areas. So a couple housekeeping items, and then I'm going to turn it over to Ron. First off, thank you to everybody who's ready to say good morning or hello in the question box. I appreciate that. If this happens to be your first time joining us, don't worry, you'll still get plenty of great information today, and we'll catch you up with links to the recordings from the previous sessions. But if you wouldn't mind looking at that for that question box and dropping me a hi or hello in there, that's how we're accepting questions for Ron throughout the webinar today. And I encourage you to put them in there. Even if we run out of time, I will still send him the question list download, and he, as in previous webinars he's done for us, will give us a general Q&A follow-up document. And then if there's specific questions, Ron likes to reach out and contact individuals to see how he can assist there. So I appreciate all the highs and hellos and good mornings. Hopefully once we get this webinar done this morning or finished up this morning, you guys will be able to get your long holiday weekend started. In the handouts area, I have for you today's slides and also that list of resources that I had failed to put in there on Tuesday. I've got it back loaded in there for you. And last but not least, I'm going to run a quick poll question just to kind of get things moving this morning. So I'm going to launch the poll question. If you would take a second to respond, and if your response isn't recording on the screen, hit the escape button to take yourself out of full screen mode and it should record then. It says, in my community, the biggest non-sidewalk accessibility challenge we face is, your options are crosswalks, traffic signals, roundabouts, on-street parking, and street furniture. I can tell you if I was voting, I would choose, let's see, oh goodness, I'd probably choose the crosswalks, because in my neighborhood, which happens to be a rural type neighborhood that's kind of been plopped out here in the middle of a bunch of farms next to a state park, we actually don't even have sidewalks. So obviously we don't have crosswalks. And it does concern me because I know the traffic on it's a township road system, and people just have a tendency to fly up and down these roads, even though there's folks out walking with their dogs and there's kids out walking. So I see that our voting has been very robust this morning. I'm going to go ahead and end the poll because we're up over 80%, and I'm going to share the results so you guys can all get a feel for what each other's challenges are. The highest challenge that was chosen was 47% crosswalks, followed by traffic signals at 20%, on-street parking at 15%, roundabouts at 11%, and street furniture at 7%. So I'll hide those results, and Ron, it is all yours.
Thank you, Victoria. Good morning, everyone. Welcome back to day 4, our final day of the session or the class. We'll continue our discussion today of the overview of elements of PROWAG. We talked about the PAR yesterday and curb ramps. Today is sort of a potpourri of topics. We'll start with detectable warnings and probably spend most of our time there because there have been a lot of questions coming in about detectable warnings. I have the questions printed out with me, so hopefully those that I don't cover, I think many of them we covered in my presentation, but those that may not be, I'll try to refer to my notes here and make sure we answer those questions as well. But then we'll get into crosswalks, which obviously is a concern, and then roundabouts, APS, street furniture, on-street parking, and temporary traffic control. So I may pick up the pace a bit for the topics at the middle and the bottom of that list, but hopefully we'll have time to get through everything and still have time for questions. So the first topic today, and one that obviously is of interest, every day we've had multiple questions come in on detectable warnings. So let's look at that. I believe I mentioned earlier, detectable warnings are a hazard alerting mechanism for the blind and low vision pedestrians. They are taught at orientation and mobility school, or O&M training as it's called, that they go through before they go out on the streets and roadways and sidewalks, that when they encounter that surface, that truncated dome surface, which you see here in the, let me get my pointer, here in the drawing, probably is the best view of it. You can also make out the domes here in the yellow surface here on the right photo, upper right photo. When they encounter that surface, they are to stop and check out the situation before proceeding, because there's some danger beyond that. And in our case, the danger is potential of moving traffic, or potentially, I'll spend a little time looking at it, could be a railroad grade crossing. But as many of you are probably aware, if you're from larger metropolitan areas, larger cities, you also find these at the edge of railroad station platforms or transit platforms, where there the danger is if someone steps off, it's more than the normal 5 or 8 inch curb height. You could fall to the tracks below and be seriously injured or run down by a train. So these are hazard alerting mechanisms. And the rule of thumb is use these wherever the curb is missing at a street crossing. So notice here in the upper right photo, where that curb is missing, we have detectable warning surface. Many of you probably have speed tables or raised crosswalks like you see here in the lower right image. Here, the sidewalk is at the same elevation as the crosswalk, as the roadway elevation is raised there at the crosswalk. So because the curb is missing at that location, we need detectable warnings. You can see the yellow surfaces there on both sides of the street. I think I mentioned earlier, this surface is not just some random surface. It's a designed surface designed to be detectable underfoot, also detectable with the cane, also to try to minimize the vibration, if you will, experienced by wheelchair users, to make it negotiable by people using crutches or canes or walkers. And right now, it is the only legitimate detectable warning surface, the truncated dome surface. Sometimes as I traveled around doing my in-person training, people would indicate that their agency had come up with their own detectable warning surface. Well, they may have, but the only one that has the approval or the blessings of the access board is the truncated dome surface. And as you're probably aware, there's a variety of different products available. Here's sort of a tile type. This is the block or brick here down in the bottom photo. This is a cast iron surface made by the same foundries that make the grates and manhole covers that we use in public works. This is popular in the northern states in snow country because it is very resistant to snow fighting equipment and weathering and so forth. But again, it's context sensitive. You need to use the product that works best for your conditions. One thing I would say though, and this I've seen mainly in smaller communities, but is do not use this. I call it the form in place method. There are these mats you can buy that have the domes built in, and you place them on the fresh concrete and then strip the mats. But I think you can see the construction quality control is quite poor. Also think about it, if you do this, say in September in the northern area where they have snow and ice, maybe by November you're already putting chloride chemicals on your roadway, and that really will destroy the domes pretty quickly. So, and then also, as I mentioned on the slide, remember we have to have color contrast. So the only way we could get that color contrast here would be to paint this surface. And so now you have a painted concrete surface on a slope, which becomes very slippery when wet. I mentioned there is a requirement for visual contrast. The original version of PROWAG, the 2002 version, said there had to be 70% contrast between the domes and the walk surface. There was some confusion about how that's calculated. And so now if you look at the 2011 version of PROWAG, it just says there needs to be good visual contrast between the domes and the walking surface. So it's a subjective matter right now. But notice here in the lower right, Yellow on light concrete like that, I've heard people tell me they don't think there's enough contrast, but that would, to the access board and to those with low vision, that would be acceptable. Notice here though, in the upper right, actually can't even see it. It's kind of a grayish detectable warning or white detectable warning on light gray concrete, and that is not sufficient contrast. One thing I should mention, and this is something we've learned through experience, I'm not sure anybody anticipated this, but you see the black on concrete here. Many of you may be using black. I'm familiar with a number of cities around the country that use black. Obviously good contrast, but what's been learned through experience is that guide dogs and individuals with certain types of low vision conditions detect that or see that or perceive that as a hole in the walkway. And I've seen dogs actually guide their handlers around what they thought was a hole in the sidewalk. So the current thinking is that in the future we should not be using black because of that issue. In fact, I've heard some informal discussions that the final version of PROWAG may say any color that provides good contrast except black. There was a question, I'm looking at my notes here, that came in, I think yesterday, that asks, struggling to find it, about yellow versus, oh, here it is. Is yellow preferred over red for low vision persons? And that's a great question. This is one of those gray areas. I realize many designers may like to use the red or the brick or kind of earth tones to fit in with a streetscape or a certain aesthetic appearance that they're trying to achieve. And I would say, you know, that red or brick tone on white or light concrete, to me, that is fine. That complies with the intent of PROWAG. One thing I would throw out there, I'm aware that the Tennessee DOT, and maybe there's others, but the Tennessee DOT has said the only color that they allow on their projects is yellow. And their reason for that is one thing for uniformity, but also apparently based on some research they've done, they found that the last color that we lose, and not only the visually impaired, but all of us, the last color that we lose as we age and our vision starts to deteriorate, the last color we lose is yellow. So I just throw both of those out there for your consideration. And then the designer can make the decision. But again, personally, I would not use black in the future in new projects. Here's some examples. Notice it's placed at the back of the curb. And one thing I will note, if you read PROWAG, it says there shall be a minimum of 24 inches of the material. And those of you who are engineers, maybe you had the same experience as me. I mean, it's been 50 years since I was in engineering school, but I still remember my professor saying, design for more than the minimum to make it safer and more comfortable and more usable for the roadway user. Always do more than the minimum. And so if someone has that philosophy in mind, which is certainly a good and appropriate philosophy, they may say, well, if 24 inches is the minimum, maybe I should cover the entire ramp. And several of you have good eyes, and you've pointed out in your comments and questions in the chat that you've seen some examples I've shown where the whole ramp is covered with detectable warnings, and that's correct. I have a few of my examples here. But personally, my recommendation would be to use 24 inches. Just think about it. For one thing, this material can be expensive, right? So why cover the entire ramp with it, more money, if you don't really need the whole ramp to be covered? Also, recall I keep talking about in these sessions that people with certain spinal cord injuries who are in wheelchairs, vibration is excruciatingly painful for them. Well, if you think about it, a wheelchair going over these truncated domes, that creates a lot of vibration. So why cover an entire ramp and expose that wheelchair user to, say 8-9 feet worth of detectable warning when you only need 2 feet. And then the third and final reason is this surface, or some of them, like I have one that I use in my samples that I pass around when I do the in-person training, that is a fiberglass composite type of material. And when that gets wet, it can be extremely slippery. And there are instances, documented instances around the country where able-bodied pedestrians have slipped and fallen on wet detectable warning surfaces. So that's, again, another reason why use more of something that's maybe a slip hazard than you need to use. So again, my advice is to use 24 inches. And some say, why 24 inches? That's also based on study and analysis of data. Remember, this has to be detectable by someone with a cane and underfoot for the low vision pedestrian. They looked at the gait of low vision pedestrians and found that if the pad is 24 inches, the low vision pedestrian, at least part of one of their feet is going to strike that surface. If it was, say, 12 inches or even 18 inches, there is the chance that a low vision pedestrian could actually step over or across the detectable warning without contacting it. So that's why they picked 24 inches. Some of you may have these directional perpendicular ramps. Notice here there's no sidewalk here on the coming in from the left. So this ramp just don't need a turning space for this sidewalk. So this ramp leads to the crosswalk, which then goes across the street. And the rule is if this landing here is less than 5 feet, we put the detectable warning at the bottom of at the grade break or above the grade break here. If this is more than 5 feet, and these photos are a little bit misleading, but if this is more than 5 feet, like this one down here, then we put the detectable warning in a radial installation. And I see that done, unfortunately, incorrectly in a number of different situations in my travels. In fact, here's one on my campus near where my desk is at the university. This in the foreground here is a driveway, and we'll talk about driveways. But notice, and I measured from here's the grade break back here. From the grade break to the curb here is 8 feet. And notice they just have a detectable warning surface here. But just think about it from the standpoint of a visually impaired, a blind pedestrian. If a blind pedestrian is on this sidewalk toward the street side, they may be using the curb. They're probably using the curb as their shoreline to follow. Well, look right here, they could go right out into the street, cross the driveway, or even out into the street because the curb is missing here, but there's no detectable warning. So that's a serious safety issue. So again, anywhere the curb is missing at a street crossing, you need detectable warnings. And notice, actually the curb is missing all the way around here. So this should have a radial installation all the way around that corner. Here's a parallel ramp. I think I said yesterday, notice that with this design, the turning space is below the sidewalk level. And so the detectable warning is part of the turning space. So if someone in a wheelchair, 2 of their wheels are probably going to go over that rough surface, which is not a good thing, but with this design, that's kind of the nature of the design. We mentioned blended transitions yesterday. Here are some examples. I think I showed you this one in the lower right. Notice the detectable warnings all the way around the corner there, wherever the curb is missing. This one, I have my red slash through it because of a couple reasons. Number one, it looks like it's too steep. Remember, blended transition, the maximum grade is 5%. That looks steeper than 5%. But the other reason I'd sort of ding them here is it's hard to tell, but this appears to be a formed in place detectable warning, the truncated domes. And to get the color contrast, they painted this. So now you have this is what I was talking about. You have a painted sloped surface, which can be extremely slippery when wet. So that's why I didn't give that a good score on that blended transition. Here, if you look at it, this looks a little weird at first, right? Because we use detectable warnings where the curb is missing, but there is a curb height here. So really, you don't need the detectable warnings. But I think what's going to happen here is, notice this street is lower level than this. Apparently, this street is going to be repaved or surfaced, add a layer of asphalt here, so the curb will be missing. But notice that is not an acceptable design. There needs to be 2 feet of detectable warning material around that corner, and you don't have that here. In fact, it looks like they had pieces left over from other portions of this project and tried to fit them in there, but that's not appropriate. Nor is this, a little bit hard to see down here, but the curb is missing around this entire corner, and they have a detectable warning here, a diagonal type ramp. But again, wherever the curb is missing around this corner, there needs to be detectable warning surface. This shows the placement of the domes. Again, lower right here looks like a blended transition. You can see the domes all the way around the corner. Here, the domes are at the bottom of the ramp where the curb is missing. And just a side note, maybe some of you have seen this. I see this quite a bit, actually. This scoring or grooving, I'm not sure what the proper word is, of the concrete at the top of the ramp. And I think people are probably well-meaning when they do that. They may be wanting to alert users to the change in slope or grade of the surface. I'm not exactly sure, but the point is, it's really unnecessary and probably a waste of the time and money needed to do that, because the truth is, someone with a cane, blind person using the cane, cannot detect that grooved concrete from the smooth concrete or from asphalt. That under the cane tip, it really all feels the same. And if you don't believe me, again, I encourage you to get a cane, borrow a cane, and blindfold yourself and walk across one of those crosswalks or a sidewalk like that, and you'll see that you can't distinguish that grooved surface from normal broom finished concrete. Here's some other examples here. This is the block type or the brick type here in the lower left. I mentioned at-grade rail crossings. Many of you may have cases where the sidewalk crosses a railroad track like you see here. And in this case, there actually should be a detectable warning surface here and probably in the foreground here outside the view of the picture to alert pedestrians that they are crossing the tracks. And notice the detectable warnings should be located so that the edge nearest the rail crossing is a minimum of 6 feet and a maximum of 15 from the center line of the nearest rail. Or if there's pedestrian gates, obviously it should be outside the pedestrian gates. So if you think about that, and that means from the rail, not from the center of the gauge of the track, it's actually from the center of the steel rail. And depending on your location or the railroad, that may place the detectable warning actually on the railroad right of way. So of course, public agencies usually don't have the authority to place something like that on railroad right of way. So you may want to alert the railroad or railroads in your community about that, because the railroads probably are not too familiar with PROWAG. But this is one case where PROWAG and the railroads do interact. And then this is not the best example because the sidewalk or the walkway is not full width as it should be, but this is a location near me. I took, I think, last summer. And notice it's a skewed crossing, which sort of complicates things as well. But notice the detectable warning surface here in the foreground, and then one in the background. And again, I have issues with the width of the path across the tracks. But my point of this slide is the detectable warning surfaces. And I know a question that always comes up, in fact, a number of you, I think every day there's been a question in the chat box about driveways. So what about detectable warning surfaces at driveways? I keep mentioning my rule of thumb is use them where the driveway looks and acts like a street. And this is a gray area in PROWAG, which I know makes people uncomfortable, but let me give you two extremes maybe, and then we can talk about what about the things in between those extremes. Let's take a driveway to a single family residential home. I would contend that a driveway for a single family dwelling does not look or act like a street. Low traffic volume, low speeds, probably a fairly tight turning radius. And so I would not put detectable warnings in general at residential driveways. Now, at the other end of the scale, let's imagine the driveway to the regional shopping mall wherever you live or work. That mall driveway is probably multi-lanes wide. It may have 2 or 3 lanes entering the property, maybe 3 or 4 or more lanes exiting. There may be dual left turn lanes. There may be 1 or 2 through lanes. There may be a right turn lane. The traffic control is probably a signal, probably a complex signal with left turn phases and so forth. There's probably a median island between the entering and exiting traffic lanes that maybe has the big sign with noting the anchor stores for the mall. I would argue that may be a private driveway, but it looks and acts like a street. So any sidewalk that crosses that driveway to the mall needs detectable warnings. And I realize there's a whole host of conditions in between those, and that's the gray area. And the way to handle that is we have to evaluate each driveway separately because each driveway is different. Even driveways serving the same facility, the driveways will have different volume characteristics, different curb radius, and so forth. So you really have to look at each driveway. And some of the factors that I would consider in making that decision, this is my list here, are the traffic control. I mentioned signals. I think if the driveway has traffic signals control where it enters the highway or the street, I would say definitely put in detectable warnings at that where the sidewalk crosses that driveway. I'd look at sight distance. Can drivers see pedestrians? And I'm thinking, visualizing, maybe a downtown in a city where an alley intersects the street. The alley may just, if traffic is in that alley, they may sort of pop out to sidewalk traffic because they're obscured by the buildings along the street. So there you may want to use detectable warning where you wouldn't at an alley that had better sight distance. I'd look at traffic volume, and I'd look at 2 parts, both the average daily traffic, but also peak hour volumes. And then I'd look at the curb radius because that affects speed, right? The bigger the curb radius, the higher speed drivers can enter or exit that driveway. So I have a few examples here I'll share with you, and I'll just kind of give you my thoughts. I was not involved in any of these projects, so I don't have firsthand experience. I don't know what the thought process was, but I observed these in my area just as a citizen, but also obviously I'm one who's interested in ADA and traffic and so forth. So these kind of caught my eye to use as examples. This is actually where I am right now. This is Morgantown, West Virginia. Off to the right here, out of view, is a gas station convenience store. And they actually have, I guess, 4 driveways. The store takes up the whole block, and there's 1 driveway on every side of the block. This is the main entrance. You can see this is an arterial roadway here, one of the higher volume roads in Morgantown. Notice this has a fairly high or fairly big curb radius. Notice on both sides. Notice it has a pork chop type island here, since it's right in and right out. Notice it has a stop sign, traffic control. And so they have detectable warning surfaces here. There's some issues with the ramps, but we don't have time to get into that. I want to mainly talk about the detectable warnings. And so I think I agree with whoever made the decision to put the detectable warnings here. I think they are needed at a driveway of that type. But this is the driveway on the west side. So now let's look on the south side of this, the same convenience store. In fact, there's the driveway we just looked at in the past. So this is the driveway on one of the side streets. Notice it's much narrower. It's one way out. Notice the curb radii here are quite a bit tighter, and they elected not to install detectable warnings where the sidewalk crosses that driveway. And I concur with that as well. I would reach the same decision as I went through my reasoning process, which I just explained to you. And then on the east side, which is actually at a different level, this, believe it or not, this is a 2-story convenience store. This is another small parking lot. I think it holds about 10 vehicles. You can see the driveway's relatively wide. It does have a stop sign, but the turning radii are not very large. And whoever designed this project elected not to install detectable warnings. And apparently the local officials agreed with that, and I agree with that as well. It's a relatively small parking lot, and I would contend a parking lot that, say, holds 10 vehicles generally, the access drives do not look or act like a street. And I don't often get by this location, but when I do drive by, usually there's, say, 2 cars in the lot, and they always tend to be the same 2 vehicles. So I assume maybe the staff parks up here, and then the customers use this lower level parking lot. But the point I wanted to make is, notice these are 3 driveways serving the same facility, but we have to look at each of them differently because each driveway has different characteristics in terms of its design, its traffic volume, traffic control, and so forth. Then I have one more example from my area. And this is my opinion. I'm just sharing my thought process with you. Again, this is a gray area, so reasonable designers or reasonable engineers may differ at how they look at this. But this is I'll call it a little hot dog shop. They have good hot dogs. They're open from, I think, like 10:30 to 3, 5 days a week. So they're not open during the morning and evening peak hours. They're not open on weekends. And you can see there's some issues with their access. They kind of have a parking lot that's very long with respect to the center line of the road, but it's not very deep, right at right angles to the road. But here we have a detectable warning here and here, and then there's another driveway here, and there's a detectable warning surface here and here. And actually, this is the other side of the street at that railroad crossing I talked about. So actually, just out of view here is another detectable warning surface for the railroad tracks. I would, in my opinion, this is sort of overuse of detectable warnings. Given the nature of this establishment, I think it would be okay to leave out these detectable warning surfaces. One of the dangers is if we overuse these surfaces, we can confuse the visually impaired to the point where they don't know were they crossing a street or actually crossing just a driveway. So I think we do need to be judicious in our use of the detectable warning surfaces. So I think maybe, well, let me go through these examples, then we'll stop for some questions. Here are just some test yourself examples that I've seen in my travels recently. And for your information, this is the block or brick type detectable warning surfaces. But notice this agency has put them on the ramp. The turning space is smooth, which is fine. Notice it's a parallel ramp, but notice there's no detectable warnings at where the actual curb is missing. The story I heard is that this agency is trying to achieve some sort of appearance or aesthetic design throughout the community, but I would argue this is not really the way to do it. For one thing, this rough surface on a ramp is potentially painful for someone in a wheelchair. It's also misleading and confusing to the visually impaired because we don't typically put detectable warnings on a ramp unless it's at a street crossing. But notice here, there is no street crossing. So, and then where there is a street crossing, where they really need the detectable warnings, there is no detectable warning. This is in the same community, a different part of town. And again, I think they're trying to achieve an appearance. Notice the granite and the brick. This is a driveway to a parking structure, which typically would be high volume. The curb radius, which we can't really see, is large. So I agree they need detectable warnings at that driveway, but note there needs to be sufficient color contrast. Here, the detectable warnings are really the same. It's a granite, but it's kind of the same gray as the concrete of the driveway. And so this detectable warning would be very difficult for a low vision pedestrian to pick up or to see. Here's another one from my campus. Again, maybe a little knowledge is a dangerous thing. Notice they've lined up the detectable warnings with the crosswalk, but there's still considerable length here where the curb is missing, but there's no detectable warning. So someone could come down this sidewalk here and actually walk right out into the street here without realizing it because the curb is missing at this location. So what they should have done here is, again, kind of a radial design. Everywhere the curb is missing here, they should have put detectable warnings around that corner. Okay, I think I'll stop there. Victoria, do we have any questions on detectable warning surfaces that came in?
Ron, we have a lot of questions. So I will pick some that seem to be general in nature. It says, in cases where bike lanes terminate and we widen the sidewalk to create a straight ramp from the bike lane to the sidewalk, where do we install the detectable warning system?
That's a very good question. And that came up last week in the work zone class as well. Yeah, because the issue that can occur is if you get a blind pedestrian using the cane going down the ramp, and there is detectable warnings because the curb is missing, they assume that that's sort of the crosswalk, when in fact it's not. We don't want pedestrians crossing there. Let me try to answer it, but then I'll also, in my response that I send to Victoria, I'll add in some additional information and some images that I used last week. But one thing I've seen, I've not actually gotten any feedback from the visually impaired, but from one thing I've seen is at those ramps, in fact, this is on the Federal Highway Administration's Office of Safety website. There's an example of this, and I'll include it in my response to Victoria. But that is putting the detectable warnings at the top of the ramp. In other words, right next to the sidewalk rather than at the bottom of the ramp. Another method that's being experimented with is to use what are called guidance surfaces, which they've been used around the world quite a bit over the years, but they're just starting to be used in the United States now. They're kind of a low profile. They're not very high, but they're a linear feature designed to sort of guide the visually impaired, maybe like let's say you have a sidewalk next to a bike lane and they're all at the same elevation. You might put that guidance surface at the interface between the bike lane and the sidewalk so that the visually impaired would not wander into the bike lane. And the city of Seattle, and I'll include images in what I send to Victoria, but the city of Seattle is experimenting with this, using it at the top of ramps. In fact, the image I'll share with you is it's a ramp where the bike lane sort of enters the street, and it's immediately adjacent to the curb ramp for the pedestrians. And the curb ramp for pedestrians has detectable warnings. The bike lane has this longitudinal surface at right angles across the top of it. So I'll share that with Victoria and she can pass that on to everybody who's here. Maybe one more question?
One more question. This one came in when you were showing the picture of the hot dog shop.
Okay, let's get back to that one.
Don't the detectable warnings need to direct the pedestrian through the crosswalk?
No, remember the detectable warnings are not used for directionality or wayfinding. They're just used for hazard alerting mechanism. But this question brings up a good point we haven't really talked about today. And notice that the curb is missing throughout this lengthy area here. I don't know what that distance is. It could be 50 feet or more. And there might be a little curb height there. It's hard to tell, but imagine maybe it's flush with the roadway. It is possible, let's say a blind pedestrian's walking from the right here toward the upper left. Notice here they have a shoreline. There's probably some grass here, so they have shorelines probably on both sides, here and then the curb. But then they get here, and notice they lose their shoreline here because they can't distinguish that asphalt from the Portland cement concrete. And if this is flush at the street here, they can't detect that curb either. And so there's a phenomenon called veering, V-E-E-R, veering. And I'll just try to illustrate it with my pointer. But a blind pedestrian, when they lose their cues, their shoreline, they may go on a diagonal path. And that is called veering. And in a wide driveway like that, with this situation, they lose the shoreline. Veering is a concern. And on a busy street, an experienced blind pedestrian would probably slow down and listen for traffic. And it's amazing to me how they can, if there's traffic here, they can kind of adjust their path and they'll move back away from the street. But I took this photo on a Sunday morning. You can see there's no traffic. If I was a blind pedestrian, I'd have some issues here because there's no traffic noise I can use to help me navigate. I've lost my shoreline. So this is I don't have a good solution, but that is a predicament, or could be a predicament for the visually impaired. But that's going to be there whether there's detectable warnings or not. The detectable warning just tells them they're about to cross a driveway. Well, maybe we'll go back to the slides and then hopefully we'll have some time at the end to address questions. Crosswalk markings. I think that was the biggest challenge this morning in the polling question, wasn't it? Yeah, almost half of you said your biggest non-sidewalk challenge is crosswalks and crosswalk markings. Here we see some of the crosswalk marking patterns. Probably the most commonly used is the standard design of just two parallel lines, but more and more I see agencies using the continental design, which we see here. And notice all the designs except this one have parallel white outer lines forming the crosswalk. This one does not, but this is still an acceptable crosswalk design. And the low vision pedestrian would say there's enough white here, whether it's paint or thermoplastic, that they can distinguish the crosswalk from the street. There's enough contrast that they could successfully navigate that crosswalk. Notice we don't see the whole intersection here, but it looks like, let's say this is a 4-approach intersection here. Under the motor vehicle code, this is a legal crosswalk, whether it's marked or not. In this one, the agency obviously has made the decision to mark it, which is fine. But, and that's a judgment decision, engineering judgment decision, whether to mark that or not. But as I think I said yesterday, once you've made the decision to mark it, we do need to continue to renew those markings, because then the low vision pedestrians are probably relying on that color contrast to be able to help them navigate the street. And also I would note that PROWAG says that the curb ramps at marked crosswalks need to be wholly contained within the markings. And I guess this one might be, but it's not clear there in the background. But again, I'll repeat that. PROWAG says that curb ramps at marked crosswalks need to be wholly contained within the markings. That's the ramp itself, not necessarily the flares, but the ramp itself. So keep that in mind. And here we see some More images here. Let me get all this up here. This is a paver block type crosswalk. Again, this is, see a side street here. It looks like maybe a T intersection, but this would be a legal crosswalk under the motor vehicle code. However, I would note that this is not an MUTCD compliant crosswalk. The Manual and Uniform Traffic Control Devices says a crosswalk must have white retroreflective lines on the outside of it, and this does not. And we can see what the driver sees. Notice these textured crosswalks without the required white lines are not very visible. Imagine driving down this street on a rainy night. I think you'd have trouble, any motorist I think would have trouble identifying that there's a crosswalk there. And also for a low vision pedestrian, there's not much contrast between that paver block surface and the, looks like the asphalt of the street. And even with markings, notice that sometimes the markings, depending on the wear and tear they've undergone or shadowing or other effects, it may be difficult to see those markings. I know there's a lot of demand for textured crosswalks. Many members of the public like them. Elected officials often want to see them. I have to admit, I'm generally not a fan of them because for a number of reasons. One, they make a rough riding surface for someone in a wheelchair. Two, they tend to be like a maintenance black hole where they require a lot of maintenance activity, maintenance expenditures. And unless these textured crosswalks have the white retroreflective lines on the outside, they do not comply with the MUTCD. So if you're going to do the textured crosswalks, this is the way to do it. Notice the textured crosswalk, maybe stamped concrete, but then notice the white retroreflective striping to comply with the MUTCD. And it's hard to tell. I don't know if this has been painted or what, but it almost looks like a sort of a shiny or semi-glossy surface. So that could be a potential slip issue in wet weather, for example. Not sure where this is, but I like this solution. Notice, I think this is a historic neighborhood, so the streets are brick, which would be rough for someone in a wheelchair. But notice the crosswalks look like they're smooth concrete or asphalt. They're well marked. It does appear, though, they have just one single diagonal curb ramp at each corner. But as far as the crosswalks look good to me. I think that's a sort of a best practice. Here are some of the crosswalk design details. I think we've talked about many of these over the last couple of days. Remember, crosswalks are part of the PAR, the pedestrian access route, so they have to comply with the PAR, meaning no more than 2% cross slope, 5% if stop, 2% if stop or yield controlled, 5% max if signalized or uncontrolled, and they can equal the street grade at mid-block crossings. Need a smooth, slip-resistant surface with a running grade of 5% maximum. And PROWAG recommends a 10-foot width, but minimum would be 6 feet, which is consistent with the MUTCD. This is an inaccessible crosswalk. I've been advised that this street cross slope is 11%. So obviously that's steeper than the 5%, even exceeds the grade of a curb ramp. So I hope this crosswalk is on this agency's transition plan. Although, would you agree that's not going to be a quick, low-cost fix? That's going to be a higher cost project to bring that into compliance. Also notice there's no detectable warnings at the curb ramp as well. So there's a number of issues here. Median islands. See these a lot. Many of you probably have them. The PROWAG says the minimum width, meaning from the face of this curb in the island here to the face of this curb, is 5 feet. So that's actually 1 foot wider than what PROWAG calls for the PAR. So Minimum width in these islands is 5 feet. And then a key distinction, if the island is 6 feet or more in the direction of pedestrian travel, where I'm running my cursor now from the foreground here to the background, if it's 6 feet or more, the island is considered a pedestrian refuge island, and we need to use detectable warning surfaces like we see here. So this is more than 6 feet. This is a refuge island, and so we use detectable warning surfaces. If that island is less than 6 feet, it's called a pass-through or a cut-through. We don't want pedestrians hanging out there, so it's not a refuge island. And in that case, since we don't want pedestrians hanging out there, we want them to think they're still in the street, the visually impaired pedestrians. So if it's less than 6 feet, we do not use detectable warning surfaces. I hope everybody's clear on that, because I see that done incorrectly at a number of places as I travel around the country. And that is a potential safety issue for the visually impaired. Sometimes I see detectable warnings in, say, a 3-foot wide island in the middle of a street. And a 3-foot wide island is not a pedestrian refuge area. But if you have detectable warning surfaces over that 3 feet, the visually impaired think that they've made it across the street when actually they're only halfway across. So this is important to do this properly. And here's an example of, this is what I'm talking about. This if it's 6 feet or more, and this looks like it's probably, say, 7 feet, we need detectable warnings here. If it's less than 6 feet, that surface should just be smooth concrete. Here's how not to do it. I guess this project is not done yet. It looks like they have some paving to do and also remove the protective covering from the detectable warning surface. But these should not actually have been installed here in the first place. This island is probably like 3 feet or 4 feet. It's less than 6 feet. And so this is not a refuge island. And so this surface should be smooth. It is not appropriate to use the detectable warning surfaces there. And I hope they're going to put some, I guess there is maybe one here. It's hard to see, but of course there should be a detectable warning surface here as well. So here are some examples. Maybe we'll start in the lower right here. We looked at this one. I won't say much more about this one. Here in the upper right, for one thing, it doesn't look wide enough. Maybe it is, but it looks more like maybe 4 feet. But it needs to be 5 feet wide. And this looks like it's more than 6 feet in the direction of pedestrian travel. So there should be a detectable warning surface here, and then behind where that couple is walking. How about this one? Looks a little different. The pedestrian path direction changes in the median, but this is okay. This is a detectable change in direction by using the curb here. And so that's fine. The one thing I might comment on is this is their detectable warning surface, this reddish brick colored. Personally, I'd like to see a little better contrast maybe between the walking surface and that detectable warning. And this is a thermoplastic pad that has the word look on it with an arrow to the pedestrian's right, to our left. And in the O's of the word look are eyeballs. And it's just a reminder for pedestrians to look to their left or to their right as they're crossing. Normally, I don't have an issue with that, but here I do have an issue because that's really more conspicuous than the detectable warning surface. And I would contend that the detectable warning surface should be the most conspicuous thing in that scene. And then this is just a mess here, both for vehicles and for pedestrians. I'm not sure this is 4 feet wide here or here for pedestrians to get disabled pedestrians to walk through there. Notice there's no real delineation of the islands for motor vehicle traffic, so I suspect drivers run into or go over those islands at night. And also notice over here, I can't see it, there's no curb ramp to get someone in a wheelchair back up to the sidewalk. But perhaps my biggest criticism of this image is notice this crosswalk. And I hope nobody has a crosswalk like that. But notice this crosswalk changes direction in the middle of the street. This is a communication violation. If you recall, we talked about subpart E last week of ADA, which says the communication with those with disabilities must be as effective as with others. But there's no way for a blind pedestrian to detect that change in direction. And we could be leading them into the island, which they could detect, but then they're not sure, have they crossed the street or what do they do? Or depending how they get lined up, we could be leading them right into stopped or moving traffic. So that's a serious communication error there in a crosswalk. Many of you may have overpasses and underpasses, like the one you see here. These also have to comply with the requirements of the PAR in terms of width and grade, cross slope, surface condition. And of course, as this slide shows, one of the issues with the overpasses and underpasses is that because for able-bodied pedestrians, they involve additional travel distance and grades or stairs, grades as you see here, pedestrians may be inclined to cross at grade. And so we do need some barriers or obstacles or something to more or less channel or funnel the pedestrians to the overcrossing or undercrossing structure. Roundabouts deserve some mention when we talk about accessibility in PROWAG. They've been a great traffic control mechanism. They have been shown to reduce crashes generally. They certainly reduce crash severity. As you see here, they can be used as an attractive gateway to communities, to neighborhoods, to college campuses. So I think they've really made a positive impact. But the one issue associated with roundabouts, especially multi-lane roundabouts that you see here, is their impact on visually impaired pedestrians. So let's take a few minutes to look at that a little bit. One thing is, of course, that with a roundabout, the pedestrian crossing is usually one car length back from the yield where the vehicles are yielding here, and they cross through a splitter island, like you see this pedestrian crossing. So that's one difference. Here in the lower right, we see a multi-lane roundabout, and we can tell from the dog guide here that this individual is blind. Now try to put yourself in her shoes for a minute. She's waiting to cross here. She can hear this white vehicle, but the challenge she faces is she can't tell if that white vehicle is going to continue around the circle like this yellow pickup truck, in which case it's really of no concern to her, or as it appears, this white vehicle is leaving the roundabout, in which case it's on a potential collision course with the pedestrian. And that happens at any roundabout, but one of the issues at multi-lane roundabouts is I'll ask you to imagine something that's not shown here. Imagine that, say a few seconds before this white vehicle arrives at that point, let's say a driver in a large pickup truck comes from the upper left here. And let's say that driver sees the dog, although notice with the hedge here and the bollard, it may be tough to see the service animal. But let's say that driver sees the dog and recognizes that this is a visually impaired pedestrian. So that driver stops here to yield to the pedestrian. That driver, though, has now created what's called the multiple threat problem, because this driver, and that driver is doing the right thing. I'm not criticizing them, but now that vehicle, let's say it's a pickup truck here, that vehicle is screening this driver such that he or she cannot see the pedestrian. In fact, they may not see the pedestrian until the pedestrian is in their lane. And the other thing, depending on the type of vehicle that's here, it may interfere with her ability to hear traffic. the scene we see here, she can probably hear this vehicle, no problem. But if there's another vehicle idling here, she may or may not be able to hear that vehicle very well. And so at these multi-lane roundabouts, there's some real issues of how do we help pedestrians, the visually impaired pedestrians, cross. And here are some possible solutions. Wish we had more time to go through these in more detail, but things like good sight distance, which is good advice for any roadway design, I think. Some have proposed rumble strips at vehicle exits so that as the vehicle leaves the roundabout, it makes an audible noise for the visually impaired. But as I think you can see from that last image, there wasn't a whole lot of distance between where the rumble strips would be and where the crosswalk was. Some folks have also proposed like the pedestrian hybrid beacon, as you see here, as a potential solution, or some have proposed using the rectangular rapid flashing beacon, although I think we still have maybe some more research to do to learn more about where this is effective, maybe where it's not so effective. But recall what I said earlier here. Sorry, I neglected to mention that. PROWAG is going to require that there be some form of signalization at new multi-lane roundabouts. That doesn't necessarily imply a standard red, yellow, green signal. It could be perhaps a hybrid beacon like you see here, or perhaps the rectangular rapid flashing beacon. Although there's still some work that would need to be done. For example, notice there's a push button here, which means there'd also need to be a locator tone so that the visually impaired can find that push button. But think about it. To me, there would have to be some sort of voice message or something to supplement this, because the pedestrian pushing this push button is not getting a standard red, yellow, green signal. Really, all the motorists are doing is getting sort of a warning device. So I think there would need to be a voice message in conjunction with this setup to let the visually impaired know what the situation is. Curb ramp placement, crosswalk placement, we talked a little bit about this yesterday. This is one of those challenges. I mean, maybe you'd like to put the crosswalk here, just extend the sidewalk, but then look at how long the pedestrian is in the roadway in conflict with traffic. It looks like maybe 100 feet or more, which is not good. This individual in a wheelchair is trying to cross here where the crossing distance is shorter, but you wonder, do drivers making this right turn, it appears to be a fairly high speed, are they able to see and stop for that individual? So maybe what we need is maybe some sort of median island here and maybe a pork chop type island here where pedestrians could cross this roadway in stages. But these are a challenge. These channelized slip turn lanes like I've depicted here. Notice fairly large radius, so vehicular speeds tend to be high. And think about the driver of this vehicle. They're looking really over their left shoulder. Would you agree? They're looking for a gap in traffic so they can merge. They're not really attentive to pedestrians who would be crossing in front of them. So this setup can be challenging for all pedestrians, able-bodied and sighted, but it's a particular issue for those in wheelchairs and especially for blind and low vision pedestrians. Here is a design that has been developed that makes this situation somewhat more pedestrian friendly. You'll notice there's a long radius followed by a short one. There's a 50 to 60 degree angle between the vehicle flows. And then the crosswalk is one car length back here. Notice it's at right angles. And these islands have to be curbed islands. These cannot be painted islands. They have to be detectable by the visually impaired. One advantage is some agencies have begun using this, and one sort of unintended consequence they found is that, excuse me, that this design also, not only is it more friendly for pedestrians, but it also reduces rear end vehicular crashes, which, as you're probably aware, is an issue associated with these right turn slip lanes. And here is some close-ups designs of these cut-through or raised corner islands, as they're called. Notice everywhere the curb is missing, where there's a crossing, we need detectable warnings. And then we have to be sure this area here is wide enough for the wheelchairs to make their turns, depending on how they're proceeding. So if the ramp is 4 feet, this area needs to be at least 5 feet here to allow for those turns. And again, those islands have to be raised. They can't be painted. Maybe I should stop here, Victoria. Are there any questions with crosswalks or median islands or roundabouts?
You know, we've got so many of them, Ron. I think it'd almost be better if you just kept going, and why don't we catch them at the end?
Okay, that sounds good. I'll keep going then.
All right.
Another important area of accessibility is pedestrian signals. And notice what PROWAG says is where PED signals are provided, they shall include accessible PED signals and push buttons that comply with the MUTCD. And here's an example of, well, here's the applicable regulations. We talked about this the first day, I think. Talked about subpart D. I think I also mentioned subpart E, which I just spoke about a few minutes ago. And this is the one, subpart E is the one that really is most prominent here when we're talking about signals, as this slide maybe shows. All of us probably are normally sighted individuals, so notice we can see the motor vehicle signal heads, we can see the pedestrian signal heads, we can see that there's a push button on the pole here, we can see that there's a marked crosswalk here. But think about this individual with the long cane. They cannot access any of that information. They can't see the crosswalk markings. They cannot tell if there's a push button there. They can't see the signal heads or which indication is being shown. And so that is a real issue for the visually impaired. And that's the basis for what's called APS, making these signals accessible to all pedestrians. So these are the elements of what's called this push button integrated APS, which is specified by PROWAG. And this is a linkage with the MUTCD as well. One thing is the speakers are at the push button. And on this unit, we can't really see the speakers because they're on the side of the unit here. But as many of you may know, maybe some of you have them in your communities, for decades, we may have used like bird chirp sounds to supplement the visual signal heads. And oftentimes those were up on poles above the roadway. And so if it was a windy day or when there's a lot of traffic noise, it might have been difficult for the pedestrian to hear those sounds. So now the idea is put the sounds, the speakers here, close to the pedestrian's ears so they're better able to hear it. There's a push button locator tone, which I'll demonstrate shortly, that sounds 24/7 to let the pedestrians with vision impairments know there is a push button. And if they home in on that sound, they can find the location of the push button. So it might go like beep, 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 beep. That sounds continuously, and that's called the locator tone. There's a tactile arrow. You can see it here. Notice a raised arrow on the push button here that points in the direction of the crosswalk. And there is color contrast between the arrow and the background, and that's for the low vision pedestrians. And then there's audible and vibrotactile walk indications. So the audible walk indication might be a more rapid tone of the locator tone. So it might go from beep, 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 beep to beep, 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 beep. That would be the walk indication. And vibrotactile means that this surface vibrates. So let's say someone has vision and hearing impairments. They would be taught at orientation and mobility training to hold their fingers on that push button after they press the button. And when the walk indication comes up, that surface vibrates. And so that communicates to those individuals that it's okay to walk at that point. And these devices have automatic volume adjustment, meaning during the day when there's a lot of street noise and traffic noise, the volume is higher than it would be at night when there's less noise on the street. That's to avoid disturbing businesses or residences that might be close to the intersection. And notice that the bird chirp sounds are no longer recommended, nor there was a technique where individuals could have hold some sort of receiver, but the feeling is people should not require some sort of, need to carry any device to access the signal system. It should be available at the corner. Different manufacturers just have different designs of where the speakers are. You see some are kind of out front, some are on the side, but the point is, notice all those speakers are close to the pedestrian, to their ears, so they can hear it more readily. Mentioned that the locator tone is a repeating sound, lets pedestrians know there's a push button and helps them find it. And the MUTCD says that tone must have a repetition rate of 1 tone per second. And we talked about that. Here's another setup. When I started into traffic engineering decades ago, we would put these push buttons on any pole out at the corner. We can't do that anymore because notice these have location information. So the push button has to line up with the crosswalk. Here's the tactile arrow. It's raised so someone can feel it, kind of like Braille, but also for the low vision pedestrian, notice that good color contrast, the yellow and black. And notice the push button really can be activated with a closed fist. So if someone has issues with their hand or fingers or something, they're still able to activate the push button. And I think we've talked about that. So the MUTCD requires audible and vibrotactile walk indications. Use the audible walk if, or I should say the audible walk, use a percussive tone if the push buttons are separated by 10 or more feet. Use a speech message if they're separated by less than 10 feet. And then we talked about the vibrotactile. So now we're going to do a demonstration, and we have to go into another mode here. So hopefully I'll get everything correct here. But we wanted you to be able to hear the locator tone, the walk indication, and then the speech message. So I need to do some things here to bring up the recording. And I think I need to get out of this. Okay, can everyone still hear me? Can you hear me, Victoria?
I can hear you, Ron.
Okay, good. I'm going to play part of this to demonstrate the locator tone and the walk indication using the percussive tone. So this would be used where the push buttons are 10 or more feet apart. Then I'm going to, and I think it's going to mute me, so I hope I remember to unmute myself. But then I'm going to stop it and say a few words, and then we'll look at an illustration of the locator tone and the voice message, which would be used where the push buttons are less than 10 feet apart. So here we go. Okay, hopefully everybody can hear me. Hopefully everyone heard that. That was, you heard first the locator tone and then the walk indication. And I mentioned earlier, like with the color black for the detectable warning surfaces, how we kind of learn through experience. What you just heard is another case of learning from experience. That tone has been fairly widely used around the country for a long time, really, since people started putting in APS. But the agencies and the manufacturers are getting pushback from many of our veterans who served in Iraq and Afghanistan and who have post-traumatic stress issues. And I think you can probably appreciate why. So I think in the future, if not already, that tone should probably be phased out in favor of more of a chirp or a beep type of tone rather than that rapid tick tone. So that was that demo. Now you're going to hear one more that you'll hear the locator tone, which is a more friendly tone to all pedestrians, is more of the chirp or the beep. And then you'll hear the speech message.
Lincoln Avenue. Walk sign is on to cross Lincoln Avenue.
Okay, hopefully I'm back on, and let's see.
You are.
I need to stop showing video. Okay, we should be back now at where we were. So hopefully everyone.
Ron, we need you to share your PowerPoint.
Okay, yeah, sorry, that's what I forgot to do.
All right.
Sorry about that. Okay, now we should be okay.
Yep, you're great.
Okay. So you heard the tick walk indication, and you also heard the voice message. Location is critical. I think I've mentioned that. Notice what we're trying to show here is that the push button is close to her hand. And also, as I keep mentioning, the speaker is close to her ears. And this push button is lined up with the crosswalk. She's blocking our view of the crosswalk really, but it is lined up with the crosswalk. And here's some more push button location criteria. Notice this comes not from PROWAG, but this comes from the MUTCD. So again, there's that kind of, just as in work zone traffic control, there's kind of that linkage or relationship between PROWAG and the MUTCD. That's also true here when we're talking about APS. Obviously, there needs to be an accessible route from the push button to the curb. Push button should be no more than 5 feet from the crosswalk, about 1.5 to 6 feet back from the edge of pavement or curb or shoulder, and a mounting height of about 3.5 feet, no more than 4 feet above the sidewalk. Here's an example. Looks like a blended transition here, and you can see the push buttons are lined up with the crosswalk, hopefully the same on the other side, because they are used for location. So that looks pretty good. How about this? Is that an accessible push button? No. That is, notice beyond the obstruction or beyond the guardrail there, someone in a wheelchair or probably even a child cannot reach that push button. So that's an inaccessible push button location. Hopefully this location is on the agency's transition plan to correct that or to fix that. Just some examples again, no more than 5 feet from the crosswalk, lined up with the crosswalk, 1.5 to 6 feet back, and there needs to be an accessible route from the push button to the street. Also notice what's critically important is, we haven't really talked about this, but the push button has to be next to or within the turning space. If you think about how someone brakes, B-R-A-K-E, how you brake a manual wheelchair, it's with your hands on the wheels. And so to brake a manual wheelchair, say on a ramp like this, someone in a wheelchair has to have both hands on the wheels of their wheelchair. And in fact, I'll show you an example here shortly. I have seen situations where the push button is here on the ramp. That's bad news for someone in a wheelchair because they don't have a free hand to activate the push button. So the push buttons need to be located adjacent to the level turning space. See the reach requirements horizontally and vertically, and again, be mindful of obstructions like this. Push button operation, hopefully none of you have this style anymore. used to be common, but you almost had to have a child's fingers to activate the push button. But imagine if someone had arthritis or other issues, or maybe was missing some fingers from an industrial accident or something like that, they couldn't activate the push button. So now we talk about, as I said, kind of the closed fist test. Someone shouldn't have to twist or grasp or pinch to be able to activate the push button. And here's an example. There are a number of issues here, including the cross slope of the street, no detectable warnings. But the point I want to make here, in the interest of time, I'll pick up the pace. Notice there is a push button next to the turning space here, but this push button is at the base of the ramp. And so someone in a wheelchair will have to have both hands on their wheels to brake the wheelchair. And so will probably not be able to reach out to touch that push button. So the solution here would be to probably move the push button here, which is properly located, move it over here, and then move this one to the location where the other one was installed. So now both of them are adjacent to the turning space. APS, when do we install it? Different entities or different bodies have different guidance. PROWAG says install APS when PED signals are newly installed, when the controller is altered, or when the signal head is replaced, or when a signal head is replaced. And FHWA guidance, notice it says APS as individual accommodation. We didn't really talk about that term, but this means if someone makes a request, that request should be evaluated, and that may cause APS to be installed or have a higher priority in the transition plan than it did originally because someone made that request. And these should be part of the transition plans. Just an example, there was a complaint against the Maryland State Highway Administration a few years ago alleging that blind pedestrians couldn't access that PED signal information. It was difficult to cross the intersection. And there's this thing again we talked about last week. APS was not installed in response to requests. Remember, that's what triggered a few of the landmark lawsuits that affect many of us now. Federal Highway Administration investigated. They found there was an ADA violation regarding APS. And so in response, the Maryland State Highway Administration agreed to develop an APS policy. And sort of in a nutshell, this is that policy. Notice that they will install APS in new construction at all signals with PED indications. Signals without PED indications will be designed for future installation. And for existing signals with PED indications where no work is planned, they're going to consider and evaluate individual requests. They'll have a priority ranking scheme that'll be part of their transition plan. And a key part, notice they agreed to form an APS committee to help develop this ranking. And this committee included individuals and organizations representing individuals who are blind. A little bit about street furniture. Obviously, this is an important part of an active streetscape, active community. So we don't want to discourage that, but it is important that these items not interfere with that 4 or 5 foot continuous unobstructed clear width. And here's a couple examples. The one on the upper right here, this is Reno, Nevada. Notice there is a fair amount of street furniture, light poles and street trees and benches, but maybe trash receptacle back there. But notice they have taken pains to make sure there's in fact, that's well more than 4 feet. There's a wide, unobstructed pedestrian path. This is a small town here in the lower left in Oregon, I believe. Very attractive, but it's kind of like an obstacle course if you're blind or if you're in a wheelchair. I think with a little bit of thought or planning, they could probably preserve all of this attractive street furniture, but still have a nice, straightforward 4 or 5 foot unobstructed path for pedestrians. So we do need to be attentive to that. And another thing, I noticed this even before COVID-19, before the pandemic, was upon us. Maybe you were having the same situation, but it seemed outdoor dining was very popular, and some communities were facing demand from the restaurant folks that they wanted more and more sidewalk width to accommodate their outdoor diners. But we still, and that's a good thing for a community. I guess that's a good problem to have, but we still need to make sure that the sidewalk remains accessible. And I think now, after COVID, with more outdoor dining and things, that problem may become more pervasive. So, but we do need to be aware of the PROWAG aspect of that as well. Accessible on-street parking. This is unique to PROWAG. ADAG talks about parking lots. And what they do here in PROWAG is talk about the block perimeter, which means all the sides of a block. If we just take say a rectangular block with 4 sides, the block perimeter would mean all the way around that block. And notice they say if the total number of marked or metered spaces is 1 to 25, there must be at least 1 accessible parking space. And notice a couple key things. Number 1, notice marked or metered spaces. If the parking is not marked or metered, this provision of PROWAG does not apply. But let's say you have 26 spaces around the block perimeter, then you would need 2 accessible parking spaces. But notice they sort of can be anywhere on that block. Like, let's say you get a resident wants parking on Main Street for some reason to access their accountant or their lawyer or their doctor or something. And you look at it, you do an evaluation, and you say, well, we can't really, for a number of reasons, safety or other reasons, we can't really put an accessible parking spot on Main Street. But under this, the way they approach this, you could put the parking, the accessible parking at the side street, on the side street near Main Street, and you'd still be compliant with PROWAG. There's a couple ways of handling it. If you have wide sidewalks or not, I'm going to skip through these pretty quickly. If you do not have wide sidewalks, put the parking, parallel parking, at the end of the block and let the individuals use the curb ramp at the corner to access the street. So this is the same thing I just showed you, just from a different perspective. Notice there's no curb ramps here. And I'm not sure I like the idea of using the bike lane to get to the curb ramp, but that's what they've done here. And where you have perpendicular or angled parking, you handle it like this. Notice the curb ramp to make the connection to the PAR. This is the access aisle here. Here's an example, I think from Austin, Texas. There's the accessible stall. Hard to see the blue paint there, but individual vehicle could park here. This would be the access aisle, and there's the curb ramp. These built-up ramps are not allowed in the access aisle. And then obviously if you're using, say, a pay station, you have to have an accessible route from the parking stall to the pay station. And meters at the accessible stalls, there are requirements for the height so that someone in a wheelchair is able to read the display information. And I think I'll stop there. We maybe only have time maybe for one or not even one question, but apologize for not being able to talk about the temporary traffic control, but I think we did have some good questions as we went through here. So I want to thank everybody for participating, and we will get the responses to the questions out to you, and I'll turn it back to Victoria.
Thanks, Ron. I think just being able to get as much information from you as possible is the best situation here. And we are unfortunately going to leave you with a bunch of homework over this long holiday weekend, because there are definitely lots of questions in the question box. So I want to thank everyone too for joining us on this webinar series. I realize a lot of folks join our webinars for continuing professional development, but I truly believe that this topic is one that can make such an incredible difference in the lives of people who need it, because I can't imagine not being able to have the mobility that I do. And if I was one of those individuals who had that disability that limited my mobility, I would want people who were true advocates for me out there working to make everything as accessible as possible. So I commend all of you for taking the time to be on this series. And Ron, thank you so much for your expertise and knowledge in this area. So I hope everyone has a great holiday weekend. Ron, is there anything else you wanted to add?
No, just add my thanks and wish everybody a great weekend.
Thank you. You as well. And I'm certain we'll talk with everybody on a later webinar. Thank you.